Let us first try to understand the concept of Bernoulli's principle. Okay. So Bernoulli's principle is one of the most important laws which is going to affect the aerodynamic behavior of your vehicles, and this is going to be one of the most primitive and elementary laws of fluid mechanics. So what Bernoulli's principle states is that pressure is basically inversely proportional to velocity. So in a fluid flow, if the pressure is going to increase, it means that the velocity is going to decrease. So what I'm trying to say is that if you have a streamline, if you have a fluid, okay, flowing like this, and if this is going to be 0.1 and if this is going to be 0.2, let me not write it as P1. So this is 0.1 and 0.2, and if pressure here is P1 and if pressure here is P2, and if velocity here is V1 and if velocity here is V2, then the relationship between P1, P2 and V1, V2 is given as follows. So it is P1 plus half rho V1 square is equal to P2 plus half rho V2 square, where rho is going to be the density of the fluid. So from this equation, if you can take a good look, this shows that the pressure is inversely proportional to velocity. So this is going to be the principle which is going to govern all the aerodynamic systems in this world, guys. So for example, if you can take your aircraft wing or your Formula 1 car, or even flow inside the carburetor of your bike, it is all based on this simple law which states that pressure is inversely proportional to velocity. Let us try to visualize this. Okay, so just in case this looks more to you like a law, and if you're not able to visualize this, then let us try to do that now. Let us assume that there is air which is flowing like this. Okay, so there is a free stream of air. So normally what happens is an undisturbed stream of air is normally termed as a free stream, and the velocity of air in the free stream is normally indicated by u infinity. So if you take any aerodynamics books or any books on computational fluid dynamics, then you would have seen a common representation with the term u infinity. This means that it is the velocity of the free stream air, the unaffected air. Okay, so what happens is that as this air is flowing in the free stream without any obstruction, let us try to add an obstruction here. Okay, something like a wall. Okay, so let us say that this is the surface of a wall. So what happens is whenever you introduce any solid in the stream of a fluid, so whenever you introduce any solid in the path of a fluid flow, then it causes some pressure difference. Okay, so what happens is as the fluid flows here, and let me just change the color now so that it will be a little easy for you to understand. So what happens is that as this streamline, let us just take this streamline for example, as it passes closer to the wall, what happens is it strikes the wall here, right? So as it strikes the wall, at this point what happens is that the pressure increases because it is hitting the wall, right? Pressure tends to increase. This is quite intuitive. So when there is a solid in place of a fluid, and when the fluid is going to strike that solid, what is going to happen is that at that point the pressure is going to increase. At the same time, the particle cannot move any further, right? That is because it is being obstructed by the wall. As a result, the fluid is going to stagnate here, or the fluid is going to stay held here, and that is the reason why the velocity drops. And the velocity will actually be zero at this point, right? So now you can see that when the pressure increases, the velocity tends to decrease. This is exactly what the Bernoulli's principle says. So what is the physical significance here that you need to understand is that whenever you produce a solid, whenever you affect the fluid flow with some kind of a solid in its path, then it causes a change in pressure, and subsequently it causes a change in velocity. So what happens is that subsequently this fluid layer will tend to revert, right? So it will tend to strike here and then it will tend to go back, right? So this is quite obvious to happen. So for example, the best thing is, like, if you cannot visualize it with air, you can also visualize it with water. So if you can hit a wall with some amount of water through a pipe, then you can see that some amount of flow is going to be reversed, right? So that is what is Bernoulli's principle. Now let us try to see about how this pressure gradient is going to be important for aerodynamics.